Hi, welcome to Code.io. In this video, we'll be solving a question called transition point. It's quite a simple question and it is based on the algorithm binary search. So if you don't exactly know binary search, please don't watch this video, learn what binary search is and then come back to this video, only then you'll understand this very clearly. Okay, so maybe I will have binary search by the time you are watching this video. I am not sure about it. We already have linear search, so if you haven't checked that out, please check that out. So now we'll get into the question. So let me first tell you what the question is. As I already said, the name of the question is transition point and the input is an array. Okay, to be more specific, it is a binary array. So what do I mean by that? A binary array is an array, quite ironic, right? Okay, so it just has the number 0 or 1 in it. Okay, see, it is an array, or you can just say it is a boolean array. Okay, so the values in the array can either be 0 or be 1. And to be more specific, the given binary array or the given boolean array is a sorted array. So zeros come at first and ones come later. So it will always be sorted. And you are supposed to find the transition point in it. So what do I mean by transition point? The index at which it moves from 0 to 1, right? So that is the transition point. So let me give you a very simple example. Yeah, so we can take this array. In this array you can see there are 6 values in the array and the first 3 are zeros and the last 3 are 1. Okay, so this is the point where it is transitioning from 0 to 1, right? I mean the index 3, that is where it is transitioning from 0 to 1, and that is the answer that we are going to return in this question. Okay, so this exactly is the question. You are going to find the index at which it is moving from 0 to 1. So this is the question and the name of the question is, for the 100th time, transition point. Okay, so now how exactly are we going to do this? Now before getting into this, we have to know one more thing as well, which is that we are supposed to solve this in log n time complexity. So if you are trying to brute force it, that is using a for loop iterating from left to right, it is the brute force approach and it will take order of n time in the worst case time complexity, but we are supposed to solve this in log n, and since it is a sorted array, we can very well use binary search in it, and that is why we are going to solve this using binary search. But before getting into the question, we have to address before getting into the main logic, we have to address the edge cases, right? So here is one such case. N is equal to 5. So what is n? The number of elements in the array, which is 4. Sorry, I said 5, right? So it's not 5, it's just 4. Okay, so we have 4 elements in the array and the array given here is 1, 1, 1 and 1. So all the elements in the array are just ones. Okay, now you are supposed to find the transition point in this array. Okay, so it's quite confusing, right? So this is where we are going to use the edge case. So this is not a conventional input, okay, because a conventional input would have zeros and ones in the array and it will be in the sorted array and you have to find the place where it is moving from 0 to 1, but it doesn't have any zeros, right? So this is the edge case that we have here, and for this particular case the output is 0 because the 0th index, right, that is the first element in the array itself is the first one. Okay, I said we have to find the transition point, the transition or the place at which the transition takes place from 0 to 1, right? So in other words, you can say it as the first occurrence of the value 1 in the array, right? So it is the first time 1 is being encountered in that array. You can see it in that point of view as well, right? So with that explanation or with that definition of the transition point, approach this question. The first occurrence of 1. The whole array is full of ones. So the first occurrence of 1 will always be the first one, right? The first element or the 0th index, and hence the output of this question is 0. Hope you understood this. This is not rocket science. It's quite easy. Transition point can also be said as the first occurrence of 1, and since this array is completely filled with 1, the first 1 is the answer, or the 0th index, the 0 is the answer. Okay, so this is one edge case that you have to address before getting into the main logic. So we have addressed this. Now we'll move on to one more edge case. Okay, so here is another one. Here the value of n is 1. Okay, and the size of the array is hence 1. Fine. And the values that are present in this array are, there are not values, there is one value which is 0. Okay, so this array has only one 0 in it and no ones, only one element, and that is a 0. So what will be the answer for this question or this particular input? The answer is -1. Why do we say that? Because no transition has occurred, or in other terms, in the other definition that we said, the first occurrence of 1 hasn't even occurred. There is no one in this array. So it is not possible to find or define a transition point here, and hence we are supposed to return -1. Okay, if you are not able to find the transition point, or if the transition point doesn't exist, we are supposed to return -1 here. Okay, so there might be an array of 100 zeros and you have to find the transition point. In that case also the answer will be -1, but you cannot straight away say it is -1 because you have to traverse the array, or you have to check if there is 1 present in that array. Without checking you cannot straight away say it, right? So in this case we are just going to see if the first element is 0, and if the first element is 0 you are just going to return -1 right away. Okay, so these are the two edge cases that we have to address before getting into the logic. Now we'll move on to a general case and we'll see how we are going to solve this using binary search. So in this input you have n equals 6, so there are going to be 6 elements in the array, and the array has 3 zeros and 3 ones. Okay, so we have to find the transition point, and if you can see, you can straight away tell that here is the transition point, right? This is the index where it is moving from 0 to 1. This we can tell by looking at it, but we'll obviously have to come up with some algorithm, right? So that is what we are going to do now. And you might know, or you should know what binary search is for this to work. So I'm just going to define a couple of variables here. One is called beginning, okay, and the other one I'm going to call it end. Okay, so just like in binary search, you are going to take the whole array and you are going to cut it in half for every single iteration until you find the transition point. Because this is a sorted array, we can do these sort of things. Okay, the condition for binary search is acting upon a sorted array, right? So here we already know this is sorted array, so we can apply this. So let me just start. Let the initial value of beginning be 0, that is where the array starts, and the end value be n minus 1 because that is the last index's value, right? So end will be 5. Now what we are going to do is we are going to find the value of middle MID. I am trying to write it clearly and it is doing some correction that is making it look weird. Whatever. Okay, now we have to find the middle ground between beginning and end. So you can do this in a couple of ways. One is beginning plus end minus beginning by 2. This is the recommended way because it doesn't let overflow to occur, but for simplicity's sake I'm just going to use beginning plus n by 2, right? But you can very well use that, and maybe we'll use that in coding, but for now we'll just use beginning plus n by 2. So 0 plus 5 divided by 2. 0 plus 5 gives us 5, 5 by 2 gives us 2, because it's just integer division. Now it gives us 2, right? So the value of middle is 2, and this is where it is pointing at. Now at this point what you have to check is if this particular element that is being pointed by the middle is exactly 1. Is this 1? No, it is not. So you can very well say that any element to the left of this, that is, we are here right at the middle. Now this is 0. So we can come up with a statement that any element to the left of my current position will always be 0. Am I right or not? Because if this is a sorted array and it has only values 0 or 1, I am at a 0. So anything to the left of me will definitely be 0, and anything to the right of me might be 0 or 1. Okay, so I think this is making sense, because this is a sorted Boolean array. If we take a 0, to the left of it will definitely be 0, to the right of it maybe 0 or 1. You may be confused with the maybe 0 or 1. Just consider this particular 0, the second one. To the left of it is definitely 0, to the right of it some zeros, some ones. Okay, now here we are at the index 2, and to the left of it is full of zeros, to the right of it is 1, but we are not going to consider that right away. Now we are just going to acknowledge this fact, to the left of us is definitely 0. So what I am going to do is, I am going to chop off this array. Okay, I am not exactly chopping it off. In the first iteration, this is what we considered, right? Beginning equal to 0, end equal to 5. We considered the whole array, because the first index is 0, the last index is 5. But we know that the transition point is definitely not in index 0 or index 1 for sure, because those are definitely zeros. Now with that note, we can reduce the size of the array being considered, and we also know that what the middle position is also not 1. Okay, so what we are going to do is change the beginning position to middle plus 1. Okay, middle plus 1, because up until middle it is full of zeros. So the transition point should definitely be from middle plus 1 to the last element of the array, right? It should be somewhere within that area. So that is what we are doing. We are just going to disregard the complete left part of the array. See, this we definitely know there is not, and this is the element that we just saw, right? Middle is the element that we just saw, and which is 0, right? So in the second iteration, we are just going to consider this half of the array. I didn't expect that color to come up, anyways, fine. So we are just going to consider this half of the array, because we definitely know there is no possible way that the transition point is lying there in that portion. That is not possible. So we are just going to consider this, and we are just going to repeat the same process. Now beginning is 3, end is 5. So what will be the middle value? 3 plus 5 by 2. 3 plus 5 is 8. 8 by 2 is 4. So the value of middle, let me just erase this bracket. So the value of middle is 4. Okay, so now we are at this particular index, middle, and the value at which or the value the middle is pointing at is 1, right? Mid value is 4 and array of mid is 1. Okay, so what that says to us, if we find a 1 in a Boolean sorted array, any element to the right of it will definitely be a 1, right? I hope it is making sense. Just like the zeros part, we are just going to consider one more thing. We found 0 and anything to the left of it will definitely be 0 because this is a sorted array. Similarly, we found a 1 here. We found a 1 and anything to the right of it will definitely be a 1 because this is a sorted array. So, we are just going to ignore this part as well. But we are going to also check one condition to see if this is a transition point. This is a statement that we already know. If we find a 1, anything to the right of it will definitely be a 1 and we can ignore that. So that we have done. But we have to check if this exactly is our transition point or not, right? Because 1 can be a transition point. So how are we going to check that? We know that this is array of mid. And array of mid and its value is 1. For it to be a transition point, its previous element's value should be 0. So that is why it is a first occurrence, right? For it to be first occurrence, the previous element should be 0. So we are going to check if array of mid minus 1 equals 0. We are just going to check that. We are going to check if array of mid minus 1 is 0. So mid value is 4, mid minus 1 is 3, index of the element that is present in the index 3 is 1. So this condition is not satisfied and hence 4 is not a transition point. Okay, I hope I am making this clear. We have found one element 1 and anything to the right of it will definitely be 1, so we can ignore that. Now we have to check if this is the first occurrence of the 1 or this is the transition point. So for that we are going to check if the previous element is 0. We have checked if the previous element is 0 and it is not, and hence this cannot be the transition point. So this cannot be the transition point. And we have also ignored everything to the right of this. Now we are going to check the rest of the array. Since we can ignore anything to the right of it, the array being considered should be changed, right? Now the end is being changed from 5 to 3 because we have already eliminated 5 because it is to the right of the 1, so it will definitely be 1, and we already have 1 before that, so this cannot be the transition point. We are ignoring that, and we know 4 is not the transition point. We just found that, so we are ignoring that as well, and hence this will be mid minus 1 because mid is not the transition point, so we can ignore that, and the array considered is being reduced to whatever the previous value of beginning to mid minus 1. So now this is the array being considered. Quite ironic, it is just one element, and we are just going to do the same process again. I'm just going to erase these things. It's quite annoying, right? So we are just going to recalculate the value of mid. Okay, now the value of beginning is 3, the value of end is also 3, and the value of mid will definitely be also 3, right? Obvious. Now we are going to check if this is the transition point. How do we do that? We are going to first check if the current value is 1. So array of mid, is it 1? Yes, array of mid is 1. Array of mid equals 1. This is true. Now the second condition for it to be the transition point, that is the important one. array of mid minus 1, right? Array of mid minus 1, is that 0? So this is array of mid minus 1 is 0. So the second condition is also checked. So both these conditions are checked and it is satisfying the condition, and hence we have found our transition point, and this is what we'll have to return. So this here is our transition point, and we'll have to return the value 3 because this is our transition point. Hope you understood this. Now we'll see one more simple example. It also may be an edge case, but we'll also see that and then we'll move on to programming. So this is the other one that I was going to tell you about. So the value of n is 6, and in the array all 6 values are 0. So this is one such other edge case that you could consider. Okay, so there is no ones in it, right? A full array is 0. So you'll have to find this, and you'll also have to return minus 1 for this because there is no transition point here. It is not possible. So how do you find this? Like, it's quite obvious. If the last element is 0, here is the last element, right? If the last element is 0, the full array is definitely 0. Hope you understand this. It's not that difficult. It is a sorted array and it is a Boolean array. So if the last element is 0, the whole array will definitely be 0. Okay, so we are just going to use that condition to rule this off, to rule these types of inputs, right? It is also an edge case, so we are going to rule that off as well, and we can do the logic that we just discussed. So this is very similar to the logic that we saw here. Only one element is present and it is 0, right? This and this can be solved in a single condition, that is the last element is a 0. If the last element is 0, just return minus 1. Here we have 6 elements and the last element is 0. Here we have only one element and also the last element is 0. So both these edge cases can be handled with single condition, that is if the last element is 0, return minus 1. If not, you can do all the process we just discussed here. Okay, so that is this. Hope you understood this logic. Now we'll try to code this and see how it goes. So here we are in Geeks for Geeks practice, and we are going to code this in Java. Okay, and the logic is very similar. You can use the same code to solve this in C++. I'm just using Java just for convenience. Okay, fine. Now before getting into the logic, we are going to solve the edge cases, right? So what is the first one we saw? Last element being 0, right? So if array of n minus 1 equals 0, just return minus 1. Because the last element is 0, it means the whole array is 0, there is no transition point, done. Okay, I hope you understand this. We are ruling two edge cases with one single condition, one element being 0 and the whole array being 0. The second edge case that we are going to deal with is full array is only of 1. Okay, so how do you find that? If the whole array is 1, you can just find that with one single condition by seeing if the first element is 1. All these conditions or all these cases are possible only because the array is a Boolean array and it is a sorted array. Okay, so we are going to see if the first element is 1. Array of 0 equals 1. If it is 1, the answer is 0 because first element is the first occurrence of 1. It is the transition point, which index is 0. So you can just return 0. So this is done. So we have dealt with the edge cases here. Now we can just write the algorithm or the binary search algorithm that we are going to use for this. So let me just define a couple of variables. Int beginning equals 0, int end is equal to n minus 1, and the binary search algorithm, right? While beginning less than or equal to end, inside which you are going to find the value of mid. And this is where I wanted you to know the other one, right? So in simple terms, you can just use beginning plus n by 2, but I don't want to do that because it is not the recommended one. You can use this one. It is quite simple. Beginning plus end minus beginning by 2. Okay. So for like, it will give you the same answer. Don't worry about it. It's better. Okay. So we have found the value of mid. Now we are going to see if this is the transition point. If not, we are just going to chop the array off. Okay. So how do we see if this is the transition point? For this index to be the transition point, first of all, its value should be 1. And the previous index's value should be 0, right? I'm just checking if mid is 1. It should be array of mid. Sorry. Okay. So we have checked if this value is 1. Now we have to check if the previous value is 0. Now in this case, we can be sure to return that mid is exactly the transition point that we want. Now if this condition is failed and the current value of mid doesn't hold the transition point, you have to chop the array. Okay. Now in that case, we can chop the array either in left side or in the right side. So how do we do in the left side? If the current value is mid, we are going to chop, if the current value or the mid value is 0, you are going to chop the left side of the array because it will fully be of value 0. If the current value is 1, you are going to chop the right half of the array. Okay. So again, other condition, if array of mid equals 1, we are going to chop the right half of the array. So end is equal to mid minus 1. But if the array of mid value is 0, beginning is equal to mid plus 1. We are chopping the left side of the array. Missed a bracket here. Okay. So this is it. This is going to traverse through the array with this for loop. This is just the binary search algorithm, right? There is nothing fancy here. And at the end, I'm just going to give a return 0 because this is an integer function, so it cannot be blank, right? So I hope this is it. Let me just run this and we'll see if this is working. So the algorithm is working perfectly fine and every single test case has been passed. Hope you understood this algorithm. I'll leave the link to this particular GFG practice website in the description. Go to that website and try and solve this question by yourself. Hope you understood this logic. If you have any questions, put them in the comments. I'll try to answer them as soon as possible. If you like the video, please like the video, and if you haven't subscribed to Code.io, please consider subscribing to Code.io. Thank you so much for watching. See you in the next video. Bye.